So I'd like to go over question 6 from the 2019 AP exam. If you haven't already, please pause the video, try the problem. So for this problem, they tell you g of 2 is equal to h of 2, which is 4. They also give you a tangent line, so that's tangent at x equals 2. The first thing you might need to notice is that this is almost written in point slope form. If you subtract the 4 from both sides, you get y minus 4 is equal to 2/3 x minus 2. That is the equation of a tangent line with slope of 2/3 and through the point 2, 4. So that's the first thing that they want you to notice on this. All right. Also, the other thing you'll notice is they told you that f was twice differentiable. They actually haven't told you anything about f yet. Don't worry, they'll mention it later on in the problem in addition to several other functions. So for part A, they ask you to find h prime of 2. The big thing they want you to notice is that slope of tangent line is equal to 2/3, and that also is going to be the derivative of h evaluated at 2. So the answer for this one is just 2/3. That's all you need to do, just give the answer, you get a point for that one. So for part B, they give us the function a of x equals 3x cubed times h of x. Write an expression for a prime of x and then find a prime of 2. Make sure on this one that you actually do write an expression for a prime of x. Some of you plug in the value like you would write a2 right away. That's usually fine, but if they specifically tell you to write an expression for a prime of x, they will mark off points if you skip straight away to a prime of 2. So for this one, you need to recognize that a of x is a product, which means you are going to use the product rule. For the product rule, you're going to use you get the first thing, which is 3x to the third, times the derivative of the second thing, which is h prime of x, plus the second thing times the derivative of the first. So that gives us 9x squared times h of x. So actually, for this problem, believe it or not, getting that far is worth 2 points. So if you got that, good job. You get 1 point for using the product rule. And you'll get another point for getting this expression. Actually, most likely, if you skip straight away to a prime of 2 and you don't write this middle step, you'll probably get the point for the product rule, but you won't get the point for a prime of x. So now we're actually going to find a prime of 2. So if I substitute in 2, I get this expression right here. I know that I have 24 if I do 3 times 2 cubed, which is 3 times 8. We already established that h prime of 2 was 2/3. By the way, if you did not get 2/3 in part A, you can still get full points on this problem. If you got the wrong answer in part A and you use that answer correctly in this equation, you can still get the 3 points for this problem. Then we get plus 36. They tell us in the beginning that h of 2 is 4. If you simplify that all out, actually you can stop at this step if you want. You don't need to go any further. You don't need to simplify. But if you go further, that's fine. You should get 160. So to get the third point for this problem, you need to get at least this far. By the way, if you got to this step right here, you still need to plug in values for h of 2 and h prime of 2. As long as you do that, though, if you get to the step below, you can get full credit, even if you don't simplify. So for part C, this part of this problem, in my opinion, is the hardest portion of any AP free response problem ever given. So if you didn't get this one, don't worry about it. However, I would like you to understand what happened on this one. So for that function, it satisfies h of x equals x squared minus 4 over 1 minus f of x to the third power for x is not equal to 2. They tell us that the limit can be evaluated using L'Hopital's rule, and they want us to use the limit to find f of 2 and f prime of 2. So let's look at this step by step. We first need to figure out the limit as x approaches 2 of h of x. There's actually two parts to figuring out this limit. I'm going to give you the first part. So we know that f, g, and h are twice differentiable functions. Knowing that h is differentiable is really helpful because that means that it is also continuous. And we know, based on what the definition of continuity is, that the limit at that point is going to be equal to h of 2. So the limit as x approaches 2 of h of x is equal to h of 2, which we know is 4. So that's a really useful thing to know. That's the first thing to notice. So for this problem, if you write out that the limit as x approaches 2 of h of x equals 4, you actually will get your first point for this one. So the second thing on this problem is that they tell you that you can use L'Hopital's rule. So usually what people want to do is they immediately will just go ahead and take a bunch of derivatives. But actually for this one, whenever you're using L'Hopital's rule, you should most likely show that you actually need to use it. So first of all, we know that if we get a 0 over 0 or another indeterminate form, that is going to be a sign that we use L'Hopital's rule. So let's do the numerator of that fraction and the denominator of that fraction. So the numerator of that fraction, the limit as x approaches 2 of this, is going to be equal to 0. That's great. That's a good sign. The denominator of that fraction, let's try that one out. We don't actually know what that f value is. If we substitute in 2, we end up getting this. However, since we know that we can use L'Hopital's rule, we know that this limit must equal 0. So, by the way, this right here is a 2. I think it looks kind of like a 4. So what we're going to do is we now have an equation. I'm actually going to continue it up here. We have that 1 minus f of 2 cubed is equal to 0. You can now solve that equation to find f of 2. And if you do that, you find that f of 2 is equal to 1. So now that actually is the first thing they asked us to find. If you get that far, you can get another point. However, if you really have no idea how to get that, which most people didn't really know to get that, you still have one other opportunity to get a point in this, and that is by actually using L'Hopital's rule. So I have this limit right here. I am going to take the derivative of the numerator and take the derivative of the denominator. So the derivative of the numerator is going to be 2x. The derivative of the denominator is, the 1 actually goes away, I end up getting negative 3 to the f times f of x to the second times f prime of x. You're using the chain rule for that one. So if you get that far, that will actually give you another point. So even if you didn't get f of 2, you might have gotten this one, which would give you another point. If you do that, you can substitute in 2. You get 4 over negative 3 times f of 2 squared times f prime of 2. So I think a lot of people got to this point, but they didn't really know what to do. And we know, based on what we had in this step right here, that this is going to be equal to 4. So unfortunately, this part of the problem is really only doable if you got f of 2 already. But once you get that, f prime of 2 actually is not that bad. You're going to solve this out, and when you solve it, you should just get f prime of 2 is equal to -1/3. And if you get that answer, you get the final point for the problem. So for part F, this one is thankfully only worth 1 point. It actually involves the squeeze theorem. It's one of the only free response questions I've ever seen that actually have the squeeze theorem involved. They don't test it very often, but I think they threw it on there just so that you can remember that it does exist and you might see it at some point. So they tell us that there is a function k that's between g and h, and they're asking you if k is continuous at x equals 2, and also to justify your answer. So whenever you see something that asks you, is this thing continuous, I want you to remember the definition of continuity. So k is continuous at x equals 2 if the limit as x approaches 2 of k of x is equal to k of 2. So that's how you can show that something is continuous. So we need to show that the limit and k of 2 are equal. So the first thing that we know is that k is between g and h. So let's first talk about g and h. So they told us that g and h and f are twice differentiable, and they also told us that g of 2 and h of 2 are both equal to 4. So that is going to help us out. First of all, if we know that g and h are continuous, we know that that thing that we just said about the limit for k is also true for those. So I wrote out an explanation that since they're continuous, which we know because they're differentiable, and because g of 2 and f of 2 are equal to 4, we know that the limit of g of x at 2 is equal to g2, which is, should also write that that's equal to 4. And the limit of h is the same. So we know we are allowed to say that this is true because of continuity. Next thing that we're going to do, we still haven't spoken about k. So we now can use the squeeze theorem. So we're going to say, so the squeeze theorem is going to tell us two things. Since we know that both g and h are 4 at x equals 2, we also know that because k is between them, it also has to be equal to 4. So that's going to tell us that k of 2 is going to be equal to 4. Also, we know by the squeeze theorem that that limit of k of x as x approaches 2 is also going to be equal to 4. So because those two are equal, that means that k is continuous. So just make sure that you specifically answer the question of whether or not k is continuous. Even if you show all of this work but you forgot to write like that last sentence, you won't get any points for it. So just make sure you answer the question asked. Everything that I wrote before the last line was a justification. And this problem, even though you did a lot of work, it's only worth 1 point.